different levels of organization of the human body. You must remember the smallest is the chemical level, right? One step higher is the cellular level, then tissue level, then organ, then system, and highest is the whole body, right? That's the organism. So those are the different levels of organization of our body. First, we'll talk about the chemical level of organization that deals with the atoms and molecules. So, first, we'll talk about the elements, atoms, isotopes, radioisotopes, and subatomic particles. So, we'll talk about those things. Then we'll talk about the chemical bonds. Bonds are attractions. How the chemical molecules are attached to each other. The chemical molecules are attached to each other by the bonds or attractions. So what are the different types of chemical bonds commonly seen in our body? Then we'll talk about the chemical reactions. You know that many chemical reactions are occurring inside the body all the time. We cannot mention the name of all of them, but what we can do, we can group them into different types. So we'll talk about different types of chemical reactions. Then we'll talk about the organic and inorganic compounds. Human body consists of both organic and inorganic compounds. We have both organic and inorganic compounds in our body. So, the most common and important inorganic compound is the water. So, water is the most important and common inorganic compound in our body. So, we'll talk about the properties of water. Other important inorganic compounds are acids and bases. Those are also inorganic compounds. So we'll talk about a little bit about the acids and bases. Then we'll talk about the organic compounds. What are the organic compounds in our body? Proteins, fats, carbohydrates. Those are organic compounds. They belong to organic compounds. So then we'll talk about the source of energy. So those are the things we'll discuss today. First, to know the chemical level of organization, you must know what is a matter. Matter is anything that occupies space and that has a mass. Whatever you see around you that occupies space is a matter. Matter exists in three forms: solid, liquid, and gaseous. You know that solid things occupy space, right? Whatever you see around you, the solid things occupy space. Liquid occupies space, right? We know that. As well as gas. Simple example, when you put gas in the tire of your car, right? It gets big, right? So that means the gas occupies space. So those are the three forms how the matters exist. Now, if you break the matters, you will find elements. Elements are the building blocks of matters. Elements form the matters. Now, if you break the elements, inside the elements, you will find the atoms. So, atoms are the building blocks of the elements. Inside the atom, you will find subatomic particles. So, the structure is like this: matter, elements are the building blocks of matters. Okay? Then atoms are the building blocks of elements, and inside the atoms you will find subatomic particles. So what are the subatomic particles? Electrons, protons, and neutrons. Okay, so those are called the subatomic particles. Okay, so that is how the structure of a matter is. Now, elements cannot be split into simpler substances by ordinary chemical reactions. It is difficult to break an element by ordinary chemical reactions, but we can do by special treatment. Until today, we have found only 92 elements. Now you see so many things. Even if you only see inside this room, you will find more than 92 matters, right? 92 different things, more than 92 you will find in this room. So matters are so many, but elements are only 92. Then how the matters are formed? Matters are formed by combining two or more elements together. That's why you have so many matters. Okay? You combine two or more elements together to form the matter. Now, elements, to indicate the element, we use one or two letters. If you use only one letter to indicate an element, that one must be the capital, uppercase. For example, nitrogen, we use N, capital N for nitrogen, but if you use two letters, the second one must be the lowercase, small. For example, sodium, to write sodium element, we use two letters, the second one must be small, first one must be uppercase. Calcium, first one uppercase, second one lowercase. But carbon, since we use only one, it is in the uppercase. So that's how the symbols of elements is written. Why we need to know the elements? Because our body is formed by elements. 96% of the body mass is formed by four elements. Four elements form 96% of our body mass. You must remember those four elements: oxygen, carbon, hydrogen, and nitrogen. So those are the four elements form 96% of the body mass. Some other elements are present in small amount in our body, but those are also very important. Although those are present in very small amount, but those are very important. What are the other elements? Calcium, phosphorus, potassium, sulfur, sodium, chlorine, magnesium, iodine, and iron. Those are present in a small amount, but those are very important. For example, calcium. If the concentration of calcium in your body decreases, get lower, then what will happen? Tetany, convulsion, seizure will occur, right? Convulsion of the body will occur, and you may die. Hypocalcemia, that is called hypocalcemia. So, you see, it is a very important chemical. You know, iron deficiency can cause what? Anemia. Have you heard that? Iron deficiency anemia will commonly here. So, those elements are also very important. So, if you see inside of an element, you will find atoms. Atom, if you see the structure of an atom, it has a nucleus and an outer shell. So this is the nucleus and this is the atomic shell. Atomic nucleus, atomic shell. Now, where the subatomic particles, electrons, protons, and neutrons are located. The protons and neutrons are located in the nucleus. So this, for example, this atom has 3 protons. Okay, these are protons, and it should have equal number of neutrons. So these 3 are neutrons. And the electrons are present on the shell. Okay, so these are the electrons. So this is an atom which has 3 protons, 3 neutrons in the nucleus, and 3 electrons on the shell. Now, protons are positively charged. So here you have 3 protons, that means 3 positive. Neutrons are neutral, no charge, no electrical charge. Electrons have negative charge. So 1 negative, 2 negative, 3 negative. Okay? So protons are, remember, PP. Protons carry positive charge, electrons carry negative charge, and neutrons are neutral. Okay? So now you see this atom has 3 protons, that means 3 positive, and 3 electrons, 3 negative. That means what? 3 positive and 3 negative will make it what? Neutral, right? No electrical charge, because positive and negative will cancel, right? Each other. So an atom is neutral. Neutral means, in this case, it doesn't have any electrical charge. No electrical charge. Because it has equal number of negative, that means electron, and positive proton. So this is an atom. Now, in most of the atoms, what you will see more than 1 shells. So here you see now this atom has 2 shells. 1 inner shell, 1 outer shell. The outer shell is called the valence. Valence shell. Okay? So if the atom has more than 1 shells, the outermost shell is called the valence shell. Okay? And if there is any electron on the outer shell, these electrons are called valence electron. On the valence shell, the electrons are valence electrons. Okay, so now the weight of an electron is so small that we cannot measure. We say electrons are weightless because it's really very small. The weight is so small that we consider electrons as weightless. They don't have any weight. Protons, 1 proton weigh 1 dalton. Dalton is the unit, or 1 atomic mass unit. Same thing, 1 dalton equals to 1 atomic mass unit. That is the weight of 1 proton. 1 neutron also weighs same, 1 dalton or 1 atomic mass unit. Okay, so that's the weight of 1 proton or 1 neutron. Okay. Now, the number of proton inside the atom is called the atomic number. So atomic number is the number of what? Good. Atomic number is the number of protons. In the nucleus. Make sense? Number of protons. So tell me, what's the atomic number of this atom?
3.
3. Because there are 3 protons, right? Now, another term we use that is called the mass number. Mass number equals to the protons plus neutrons. So what is the mass number? 6. Make sense? Protons plus neutrons. 6 is the mass number, 3 is the atomic number of protons. Is it clear? And in an atom, normal atom, the number of protons and neutrons are equal, as well as the number of protons and electrons is equal. Make sense? And that makes the atom what? Electron and proton, that means equal number of positive and negative, right? Makes the atom neutral. Okay, now this equal number of protons and neutrons in the nucleus is very important. For any reason, if the number of proton changes, for example, 1 neutron is less here, so 3 protons, 2 neutrons. If the number of neutrons changes, that atom is now called an isotope. So, if the number of neutrons is different than the number of proton in the nucleus, that atom is called what? An isotope. That atom is called an isotope. Is it clear? It could be less than the proton or more than the proton, but different. That is an isotope. Now, sometimes if the number of protons and neutrons are different, then what can happen? The nucleus of this isotope can emit radiation, can release radiation because of this imbalance, unequal number, and imbalance will be produced here, and that unrest or instability of the nucleus can produce radiation and release it. And in this case, this isotope will be termed as a radioisotope. So not all isotopes will release radiation. If the isotope releases the radiation, that is called a radioisotope. Make sense? Okay. Another thing is important to know is that the protons and neutrons are stable, they don't move, but electrons orbit the nucleus. Electrons move very fast around the nucleus, orbit the nucleus in circles around the nucleus. And now if you see here, you see a helium atom. It has 2 electrons in the shell, and in the nucleus it has 2 protons and 2 neutrons. In the right side picture, you see a cloud around the nucleus. That is called the electron cloud. What is that? Around the nucleus, you will see a cloud in an atom. Just think that when we draw an atom on a paper or on the board, we draw in 2D. But actually, the atom is like this, 3D, round, okay, like this. And this is the shell, right? Atomic shell, makes sense? Nucleus is in the center. So this is the atomic shell. And now you think that electrons are moving in different planes. Like a couple of electrons are moving this way, a couple are moving in this way, a couple are moving in this way, makes sense? Now, just think that you have many keys and you tie all those keys with a string and move very fast. Sometimes we do that, right? Move like, and you see the whole circle, right? Is formed if you move very fast. So now think that many electrons are moving in different planes around the nucleus. So you will see like a ball, sphere, okay? Cloud. That's the electron cloud, okay? We see around the nucleus. Okay. Only all the atoms have protons, neutrons, electrons. Only exception is the hydrogen. Hydrogen atom doesn't have any neutron. This is only exception, so you need to remember that. Hydrogen atom doesn't have any neutron, only proton and electron. Okay. Now we'll talk about the ions. We know that atom is electrically neutral, no electrical charge because it has same number of electrons and protons. Protons are positive, electrons are negative. They cancel each other. No electrical charge. Now you see here, you have two atoms close to each other. This one has two protons, two neutrons, two electrons. This one has, for example, three protons, three neutrons, and should have three electrons. Three electrons, okay? So these are negative electrons, 1, 2, 3. This one has two electrons, and these are protons, positive, 1, 2, 3. Okay. Now, if this atom has an extra space to receive another electron, there is an empty spot or seat to receive another electron. When you will bring these two atoms close to each other, what will happen? One electron may jump from here to here. Like, oh, I got another spot, okay? Good spot. So I will jump to that spot. So it will jump from one shell to the other shell. And now, what will happen then? So if this one jumps here, so this one will lose the electron, right? And this one will gain the electron. So now you tell me, this one has how many negative?
4.
How many negative here? 3. How many it had before? 2, right? So it got one more from this one. So now it has 3 negative, right? Electron. And how many positive? 2. So this will become what? Negatively charged atom, right? So it will become negative. And this one has lost one electron, one negative, right? So now it has 2 negative and how many positive? 3. So it will become what? Positive. Okay. When an atom gets electrical charge, it could be positive or negative, doesn't matter. When an atom gets positive or negative electrical charge, it is called an ion. So this is positive ion, this is, negative ion, this is positive ion. We know that atoms are neutral, no electrical charge. When the atoms get electrical charge, positive or negative, both are now ions. Make sense? So ions have what? Electrical charge. Atoms don't, right? Okay. So now if I ask you how an atom can become an ion, how an atom is converted to an ion? By gaining or losing electron. Make sense? So by gaining or losing electron, an atom becomes an ion. Make sense? If you lose electron, you will become what? Positive or negative? You lose. Positive. If you gain electron,
Negative.
it will become negatively charged ion. Positive ions are called cation, and negatively charged ions are called anion. So this is an anion, this is a cation. Now when they are close to each other, we know that positive and negative, when you bring close to each other, what will happen? They will attract each other, right? We know that positive will attract negative. And that is the attraction called the ionic bond. Ionic bond. Ionic bond is the attraction between the cation and anion, the positive and negative ions. Make sense? We know that positive and negative, they will attract each other, and that is the bond, attraction, called the ionic bond. And the process how an atom becomes an ion, that is called ionization. So we have seen by donating or receiving the electron, ions are formed, so that is called the ionization. Is the process how an atom becomes an ion. Chemical bonds. Three types of chemical bonds are the most common in our body. What are those? Ionic bonds. We have already talked about the ionic bonds. By donating or receiving the electrons, ionic bond is formed. Ionic bonds are medium strength bonds, not too strong, not too weak. Another type of bonds, those are called covalent bonds. Very strong bonds. How the covalent bonds are formed? By sharing the electrons, not donating or accepting, but by sharing. What is that? So for example, this is an atom. Okay, it has 3 protons, 3 neutrons, and should have 3 electrons. Okay, so these are the electrons, protons, neutrons. Now another atom is attached to it. This is another atom. It has 4 protons, same number of neutrons, and 4 electrons. Now you see here how the covalent bond is formed. this one has 4 electrons, this one has 3 electrons. Now, when they will come close to each other, what can happen? The some of the electrons on their shell may get attached to each other. It's not going or jumping to the next, but they are physically getting attached to each other. So here, 2 of these, this one and 2 of this one, they got attached to each other. And this is called sharing of electrons. This is the covalent bond. Okay, L-E-N-T, covalent bond. Very strong bond between the atoms. When you will see the chemical formula of different compounds, you will see, like for example, if this is a carbon, this is another carbon, but how we will write this? C double bond C. How many pairs are connected to each other? That is indicated by the line. Here 2 pairs, 1, 2, so we will use 2 lines. That's what you will see in chemical formula like this. Like this, okay? So how many pairs that form the covalent bond? Hydrogen bonds are the weakest bonds in our body, and hydrogen bonds connect the water molecules in our body. Hold the water molecules to each other. Now, you know that water consists of 2 hydrogen, weakly positive, and 1 oxygen, which is weakly negative. Okay, so this is H2O, water molecule. This is another water molecule, positive, and oxygen, weakly negative. So when the water molecules will attract each other, this weak positive will attract this weak negative, and a bond or attraction will be formed. That is the hydrogen bond between the weakly positive hydrogen and weakly negative oxygen. And this is a weak bond, but it is the bond that holds the water molecules together in our body. This is a funny conversation you see between 2 atoms. Okay, one atom is telling that, damn, I lost an electron. The other one is asking, are you sure? The first one is saying, I am positive. So by losing an electron, you will become what? Positive, right? You will become positive. Make sense? Okay. We have talked about the process, ionization. You see here, sodium and chlorine, 2 atoms. And when sodium loses an electron, because there is an empty space here, it's not here, so it will become positive, and since this one is getting electrons, negative, it will become negative. So sodium will become positive, chlorine will become negative, and they will attract each other. That is the chemical bond to form sodium chloride. Those 2 things will together will form the sodium chloride. So you see the process of donation and acceptance, and after that the atoms become positive and negative. That means ion. This is cation, this is anion. Here you see 2 nitrogen atoms have shared some electrons. So we can write this 1, 2, 3. 3 pairs are being shared. Water. These are hydrogen bonds between hydrogen and oxygen of water. And one way you can see that water molecules are attached to each other. Surface tension of water is formed by the hydrogen bonds. Water molecules are being held together by the hydrogen bonds. On the surface of the water, right? Sometimes you'll see tiny flies, they can easily walk because of that surface tension formed by the hydrogen bonds. Another way you can test, if you dip your finger in water and take it out, you see a ball of water is formed, right? That means what? Water molecules are trying to stay together within that ball, right? And when it will drop, it will also drop as a ball, right? So water molecules always try to stay together. Otherwise, they will go in different directions. That doesn't happen, right? So that is the example how the water molecules are connected by the hydrogen bonds. Yes.
What is the cause of the surface tension again?
Example?
The cause?
Cause is the hydrogen bonds. Hydrogen bonds are connecting the water molecules, holding the water molecules together. Hydrogen bonds hold the molecules together. Make sense? Yes? Okay. Chemical reactions. So we have talked about the chemical bonds, attractions. Now we'll talk about the chemical reactions. As I have mentioned, thousands of chemical reactions are being taken place inside the body, right? We can group them into few types. The common types of chemical reactions are synthesis reactions, decomposition reactions, and exchange reactions. Those are common types of chemical reactions in our body. First, synthesis reaction. Synthesis reactions form larger and more complex molecule from the smaller and simple molecules. I am repeating again. Synthesis reactions produce larger and more complex molecule from what? Smaller and simple molecule. So, an example, glucose. Glucose are very simple carbohydrate molecules and very small. Glucose, small and simple. Most simple carbohydrate molecules. Now, by synthesis reaction, glucose molecules will be converted to one large complex molecule that is called a glycogen. So glycogen is large and complex molecule. So you see, by synthesis reaction, small simple molecule is converted to a large complex molecule. Okay? Glycogen. So this is an example of synthesis reaction. Decomposition is just opposite of synthesis. So this is the decomposition. Decomposition reaction is opposite of synthesis reaction. That means the large complex molecule is broken to release simple small molecules. That is the decomposition. Large complex molecule is broken to produce or release simple small molecules. Make sense? Have you heard the word decomposition?
Yes.
Yeah, we commonly hear, right? Like body, after death, the body has been decomposed. No? That means been destroyed or broken. Okay. So, those are synthesis and decomposition reaction. Another example I can give you, you know that amino acids, these are amino acid molecules, small simple protein molecules, and when amino acids join together by peptide bonds, these are the peptide bonds, they link the amino acids together, okay, form the amino acid chain, which is the protein molecule. So, a number of amino acids, small amino acids or amino acid molecules are joined or linked by the peptide bonds. Peptide bonds to form a large protein molecule. So this is an example of synthesis reaction. Now, if you break the protein peptide bonds, then what will happen? The amino acids will be released from there, right? That is the decomposition. If you break the peptide bonds, then that is the decomposition reaction. Okay, decomposition reaction. We release the amino acids. Exchange reaction. When two molecules exchange their parts to form new molecules. I am repeating again. In exchange reactions, two molecules exchange their parts to form new molecules. Okay, for example, sodium hydroxide, hydrochloric acid. So this is sodium hydroxide, this is hydrochloric acid. When the reaction occurs between these two, this part of sodium hydroxide will go here and this part of hydrochloric acid will come here. So let's see what happens. If this part comes here, it will become sodium chloride, that's the salt, and when this part will go there, here, that will form water, H2O. So you see, two molecules have exchanged their parts to produce new molecules, salt and water. So that is an example of the exchange reaction. Two types of compounds form our body, organic and inorganic. I have already mentioned important inorganic compounds are water, salts, acids and bases. Those are the major inorganic compounds. If you see the chemical formula of inorganic compounds, you won't see, usually you won't see carbon. For example, all these are inorganic because sodium hydroxide is what? A base, we know that. Hydrochloric acid is what? I have already mentioned. Hydrochloric acid is what? An acid. So, base, acid, salt, you see? Salt, acid, base. So we have everything here actually. Sodium chloride is the salt we eat. So all these are inorganic compounds and no carbon is here. So inorganic water is another one. So you have actually all of those here. That's interesting. So you have all important inorganic compounds are in this reaction. Base, sodium hydroxide, acid, hydrochloric acid, salt, sodium chloride, water. And those don't have carbon. So usually inorganic compounds don't have carbon. Organic compounds are proteins, carbohydrates, fats, and nucleic acids. Those are the nutrients. We know that. The food we eat, right, they become the nutrients, proteins, carbohydrates, fats, nucleic acid. And very often we see carbon, many carbons in organic compounds. And if you see a structure, chemical formula of an organic compound, you will very often see carbons. Double bond, single bond, triple bond, they are connected like this. So the main framework is formed by the carbon in case of the organic compounds. So we know these are the inorganic compounds, and most common and important one is the water. Water forms 60 to 80% volume of the living cell. 60 to 80% volume of a living cell is given by the water. Water has some important properties that help us a lot. What are the important properties of the water? Number one, high heat capacity. Water has high heat capacity. What is that? Water will not turn to hot or cold quickly. That is the high heat capacity. It will not get hot or cold quickly. Make sense? If you put some water in a pot and put on the stove, water to boil, and put your finger, you will see it takes long time to heat the water, to make it hot. It takes long time, right? Slowly it will turn to hot. Now once you make the hot water, for example coffee or tea, you drink for a long time, right? Because it stays hot for a long time. It will not quickly turn to cold. Make sense? That is the high heat capacity, which is very helpful for us because our body is mainly what? Water. Right? Your body is mainly water. Now, if your body quickly turns very hot or quickly gets very cold, is that good for you?
No.
No, not at all. Right? So, if you go outside in winter, your body will suddenly, the body temperature will drop. Right? That doesn't happen. Okay? So, water high heat capacity is very important for our survival. High heat vaporization. That is another important property of water. What is that? Water will not turn to vapor or gas quickly, which is very important. Our body, again, our body is mainly water. And if the water quickly turns to air or gas, vapor, then what will happen? Your body will shrink. All cells will shrink like 60 to 80% volume. So what will happen? Your body will get very small. Actually, will not survive. So that is another very important, right, property of water, that it doesn't turn to air or gas quickly.
So it just has like a high boil point.
Yeah, after boil, it will start to turn to vapor. Okay. Body's major transport medium is the water. We know that blood transports the chemicals, right? Gases, nutrients, metabolic waste, hormones, and your blood is mainly formed by water. So water helps in transportation of the chemicals. Necessary part of hydrolysis and dehydration synthesis reaction. In many chemical reactions in your body, water participates. Just know that. In many chemical reactions, water participates. How? In some chemical reactions, water will split. Water will release hydrogen and hydroxide. In some chemical reactions, water will be formed or produced. For example, I have already shown you here. You see, in this chemical reaction, water is formed. Water is formed. So, in some chemical reactions, water will be produced, and in some chemical reactions, water will be used. So, dehydration, hydrolysis, and dehydration synthesis. Hydro means what? Water, right? Lysis is the breakdown. So that is hydrolysis, breakdown of water. And this is synthesis, production of water. So just know that in many chemical reactions in our body, water is either used or will be produced. Cushioning, protection. Around some important organs in your body, you have fluid, which is formed by mainly water. Around your brain, you have the cerebrospinal fluid, CSF, that protects the brain, right? Around your heart, you have the pericardial fluid. Around the heart, you have fluid. Around the lung, you have fluid. So, those are the places where water is present and protects the important organs in our body, okay? Providing cushion. So those are the important properties of water in our body, how they help. Now we'll see other inorganic compounds, acids and bases. Although these are the things you should learn in chemistry, I'll just briefly go over these things, very important. So acids, how to define an acid? Acid is a chemical that quickly releases hydrogen ion. So acid is a chemical that can quickly release hydrogen ion. Very simple definition. Base is a chemical that can quickly remove hydrogen ion by producing hydroxide. Okay? So this is the definition of, simplest definition of a base. Bases remove the hydrogen ion and acids produce the hydrogen ion. I have shown you in the reaction I wrote here. The very commonly seen acid is the hydrochloric acid. Why this is an acid? Because it will quickly release hydrogen ion. It is ready to give hydrogen ion. Makes sense? It is always ready to give or release the hydrogen ion from it. That's why it is an acid. Base. So this is an acid which quickly release hydrogen. Base. The most common base is sodium hydroxide that I wrote there. Sodium hydroxide is a base, typical base. Why it is a base? Because it will quickly produce OH and sodium. Now, by producing OH, base does what? Quickly remove hydrogen ion. So, for example, in your body, the hydrogen ion concentration has increased. Hydrogen ion concentration has increased. So, that hydrogen should be quickly removed. Who will do that? The base. Because we know that base quickly removes hydrogen ion. How? By producing OH. See here what will happen. Base will quickly produce OH and this OH will bind with this H. So what will be the result? Water. Make sense? So base will quickly produce OH, and that will bind with the free hydrogen and will produce water. So this hydrogen will be removed. Water is neutral. So no more this hydrogen is free here. It will bind with OH and will produce water. Make sense? So you see, base will remove the hydrogen by producing OH. Make sense? And acids will release the hydrogen. Now, you need to know a very important relationship. What is that? Relationship between the hydrogen ion concentration, pH, and acidity. If the hydrogen ion concentration increases, the pH will go down. That is the relationship. Increased hydrogen ion will decrease the pH. Make sense? Always remember this is the relationship. And more hydrogen ion, less pH means more acidic. Okay, so this relationship is very important. You all should never forget. Okay?
So, if the hydrogen goes down and pH goes up?
Goes up. Okay, and it will become alkaline, less acidic. Make sense? And if hydrogen ion concentration increases, pH will go down and it will become acidic. Make sense? Less pH means acidic, means more hydrogen ion. Is it clear? Mm-hmm. Okay. And this is an important relationship. That's why we say pH is what? Negative logarithm of hydrogen ion concentration. pH is the negative logarithm of hydrogen ion concentration. That means opposite direction, negative logarithm. Okay. If pH goes up, if the hydrogen ion goes up, the pH will go down. pH is the negative logarithm of hydrogen ion concentration. They will go in opposite direction. Okay. If the pH is 7.0, that is called neutral. 7.0, that is neutral. We know that, I have mentioned, water is neutral. So the pH of water is 7.0. If the pH goes above 7.0, it is alkaline. If it goes below 7.0, it is acidic. Okay? So that scale, if you see the pH scale, it goes from 0 to 14. Okay? Middle is 7.0, which is neutral. 0 to 6.99, that is acidic, and from 7.01 to 14, that's alkaline. Okay? So this is alkaline, this is acidic. As you will go down more, it will become stronger acidic because pH is going down. If you go up gradually, the alkaline, it will become more alkaline. Okay? So that's the scale, pH scale we use.
Actually, what pH to me, real quick, refresh me what pH is.
The negative logarithm of hydrogen ion concentration, that's the definition. It is directly related to the hydrogen ion concentration in the solution.
Oh,
Okay? So if hydrogen ion negative, that means opposite. Okay? So if hydrogen ion concentration in a solution goes up, then the pH will go down.
Okay.
That means it will become more acidic. More hydrogen means more acidic. Okay? We know that acid do what? Acids release hydrogen. Right? keep it. So more hydrogen means more acid. Okay. So if the pH is below 7, that means 0 to 6.99, it is acidic. If it is 7.01 to 14, that's the alkaline or basic. Okay. Here you see they have shown the pH scale, and that scale is showing neutral is 7, and the scale is from 0 to 14. Above the 7, all those things are alkaline. For example, egg, household bleach, other things, all those are alkaline. If you go below 7, coffee, wine, lemon juice, hydrochloric acid, right? Those are acidic. And the strength will go up as you will move away from 7. As you move away from 7, the strength increases. Okay? Let's stop here. We got a lot of information. I hope you'll remember.